Hi children, I am Mr.Prabhu R, Mathematics faculty in Kumudutira Residence Center School, Shikaripura. Today, I am going to introduce the new chapter, that is second chapter, Polynomials. As you know, in your previous classes, the meaning, the classifications and many more of them are related to words about the polynomials. Today, I am going to introduce the polynomial chapter. Let us see. In your previous classes, you have already thoroughly studied the classification. Which are the classifications for the polynomials? Monomial, binomial, trinomial and polynomial, if the terms are more than 3. So, these are the major classifications. Exactly, what is the meaning of the polynomial? Yes, meaning first. Meaning of the polynomials. Children, you already know the polynomials, it contains more than 2 terms. Simply, you can call it as polynomial because it contains more than 2 terms. That is no algebraic terms. But actually, what is the real definition or meaning itself? Yes, the polynomial is an expression consists of variables and coefficients. And which involves fundamental operations like addition, subtraction and multiplication only. So the polynomial is an expression consists of variables and coefficients, in which it also involves the fundamental operations like addition, subtraction and multiplications, including the non-integral exponent of variable, So, examples. Consider any example. Look over here, the exact meaning. It involves fundamental operations. When variables and coefficients are together, in between them, the fundamental operations. So, which are those addition, subtraction, multiplications, including the non-integral exponent of variable. Consider the variable, they should not contain the non-integral powers, that is exponents powers. For example, consider x plus 1 of the binomial example. Next one, x square 2x plus 4, any one of the example. Consider u square plus root 7 u plus 3. Like this, you may consider any examples. These are all the examples for the polynomials. Why these are the examples for polynomial? Consider here in this expression, polynomial, x is a variable in which degrees is 1, powers is 1. Here also x is there, variable in this expression, I mean it is a polynomial. In this polynomial, the x is a variable. Here its power is 2, 1. Here 2, 1. There is no non-integral powers. Here also 2, 1. Means we should consider their powers also. So what do you mean by this powers? Powers are nothing but integral powers are non-negative. Here integral powers are nothing but non-negative. So that is why. So here all are positive and hence they are more than 1, 2, 3 like this also. Not only 1, 2, they are more than that numbers also. Consider any integers. But they are not negative. So that is why. This is one. Also I will take one example, that is root x plus 1. So consider this is not a polynomial. And also of course you can take one more example. X square plus 3x plus 2. If I write like this is not a polynomial. These are not polynomial. Why? Suppose you can express them in powers. X can be expressed in the powers of x. There comes negative. Look here, it becomes negative. This comes less than 1. So that is why these are the examples. These are the best examples. Not only these, you can take any more examples, but conditions you should remember. There should be their power should not be power should not be negative. Means non-integral powers or exponent should be required. So these are not polynomials. So this is one. In the same time, we must know about the degrees of polynomial. What do you mean by degrees of polynomial? Now, what do you mean by degrees of polynomial? Suppose you have learned in the previous classes, that is zeros of a polynomial. That is zeros of a linear polynomial, zeros of a, now in this here, zeros of a quadratic polynomial also you can study. So that, what do you mean by zeros of a polynomial? Zeros of polynomial. Consider any polynomial in which the value of the variable is 0. The value of the variable means the polynomial variable, the polynomial which contains the variable, sum of its value, when you want substituting you can get the sum value. So that is why the polynomial becomes 0. Hence that is known as zeros of polynomial. Okay. Now consider degrees. Before that we can consider the degrees. Degree of polynomial. So what do you mean by degree of polynomial? I will explain this along with the examples also. Degree of, let us assume, now let us x plus 1. Consider let x plus 1. Okay. So here, next another one, x square plus 2x plus 1. Consider these two. Okay. Here what is this? This is a polynomial, this is also polynomial. So suppose p of x is a polynomial. You can express this one by x plus 1 like this also. Here what is the degree? Degree means always the polynomial which contains the variables of exponent, means greatest powers of the variable. In a polynomial, the greatest power of a polynomial is nothing but degree of a polynomial. What do you mean by degree of a polynomial? Degree of a polynomial is nothing but the greatest power of a variable in a polynomial is known as degree of polynomial. In which consider it is, what is degree of polynomial? Here x to the power of 1. Here exponent power is 1. Here exponent power is 2. Therefore it is degree of polynomial. It is 1. Degree of polynomial is 1. Here degree of polynomial is 2. Consider any other equation, that is ax cube, otherwise 2x cube minus 3x square plus 2, like this, 2x plus 1. Consider this is also polynomial. In which is the degree of a polynomial? The degree of a polynomial for this expression is 3, because the variable is same variable, always polynomial having the same variable, in which the powers are different. Here it is 3, here it is 2, here it is 1. So let us consider for degree of a polynomial, that is 3, because it contains the greatest power. 3 is the greatest power. So instead of this, if any non-integral exponents are comes, so that is why that is not a degree polynomial. Hence that is not considered as degree. So let us see next, what do you mean by linear equations or linear polynomials? Now see here. So based on the polynomials, there are 3 major polynomials classified over here in your syllabus. That is linear polynomials, quadratic polynomials, and cubic polynomials. So in the last last year we have already studied these linear polynomials. These linear polynomials example is, for example, PB any polynomial. Consider if it is the variable is x, consider x only. If the variable is y, consider p of y. If the variable is u, consider p of u is a polynomial. So p of u, it is nothing but x plus 3. I will take this one example. Okay. So p of x is equal to x plus 3. Not only this, we can take any values, but consider any binomials also. That is also nothing but what? Linear polynomials. Means here, what about its general form? This is one example. What about its general form? That is ax plus c. Here a and c are any constant value, nothing but real numbers. So here x is a value of variable, means algebraic variable. Here its power c is 1. Always degree 1. If the polynomial contains its degree of 1 is nothing but linear polynomial. So hence it is known as in the general form ax plus c. Okay. Now what happens is quadratic polynomials. What do you mean by quadratic? Quadrate. The meaning of quadrate means it is square. Okay. By using some other language. So squares. That is why square of the polynomials. Therefore their variables always exponent power start with 2. It means the highest power is 2. Okay. Let us assume it is a polynomial of x variable. So x square plus 2x minus 3. Consider any one example of this one. Okay. So by using this expression, not only this one, we can express any different kinds of the. So, but their power should be what upon highest power, greatest power is 2. That is why it is quadratic polynomials. What happens in general form? Now its general form is ax square plus bx plus c. Look over here. These are the example. These are the general forms. Consider. Here, one condition applied. If it is a is equal to 0, what happen? That is not a linear. Here also, a is equal to 0, what happen? That is not a quadratic polynomial. Because if a is equal to 0, look here, it becomes 0, then constant remains. Means any real number remains. That is why it is not a linear. Here also, if you value of 0, instead of a is equal to 0, the whole value becomes 0. Then b x plus c goes to linear polynomial. That is why. So by this condition, that is a is not equal, but a is not equal to 0. So in this already you know that there are many examples for polynomial. Consider any one of the example. Square root 2 of x cube plus square root 5 of x square plus x plus 1. Consider this one example for polynomial. Okay. So here which is the greatest power? 3. That is why it is known as cubic polynomial. The degree of the given polynomial is 3. It should be considered as cubic polynomial, in which what is the general form for this polynomial? That is ax cube plus bx square plus cx plus d. Here c is the last term. Here d is the last term because the polynomial increases its terms. That is why. And here also a is not equal to 0. Suppose what happen? A is equal to 0. What happen? It becomes 0. Then automatically this leads to your quadratic polynomial. Okay, that is why based on that a is not equal to 0 condition, we may explain these three kinds of the polynomial. That is linear polynomials, quadratic polynomial, cubic polynomial. Simply remember, very simple. Linear polynomial means their degree should be 1. Quadratic means their degree should be greatest power 2. Cubic means degree should be 4. The same way, assume that different kinds of the polygons. Okay. Now let us consider zeros of polynomial. What do you mean by zeros of polynomial? Now assume any polynomial. Their polynomial value must be equal to 0. Then that is called as zeros of a polynomial. So how we can assume that? By taking one example. Consider one of the example. 3x square minus 4x plus 3. Okay. Start. Okay. Assume here one of the example of the polynomial x square minus 3x minus 4. You know that already how to substitute the values. That is, for example, x is a variable. By putting x value as 0, 1, 2, like this also. Consider any whole number, any natural number, or any integer also. Consider any one integers and one positive and one negative numbers also. So let us assume that p of x, because x is a variable, that is why I took polynomial of x. That is why polynomial square minus 3x minus 4. Now substitute these values. What happen? P of minus 1, it is equal to minus 1 square 3 minus 1 minus 4. So this is minus into minus plus 1. Okay, minus into minus plus 3 minus 4. So 4 minus 4, you will get 0. This is 1. Now also similarly, this is one value. Now take another value, that is P of 4. It is equal to, that is 4 square minus 3 into 4 or 4 plus minus 4. Okay. Now 4 square means 16 minus 12 minus 4. So it is equal to 16 minus 12 is 4 minus 4. It is equal to 0. So consider both the example. This is 1, okay, and this is 2. Okay. Here what happened? The values of the polynomial become 0. The values of the polynomial become 0. Whenever by replacing the x value by minus 1, by replacing the x value by 4. That is why by replacing the variable by any real number, consider k is a one real number. Okay, any real number. If you replace the variable by any real number, suppose you get the polynomial value is equal to 0, then that is known as zeros of a polynomial. If it is a linear one, then it is zeros of linear polynomial. If it is a quadratic one, then it is called as zeros of quadratic polynomial. That is the example. Here, this is the one examples I given over here. Under this, we can discuss the so many examples. That is very easy to solve and substitute over here. In the same way, you can take the any integers also. So this is called zeros of a polynomial. Now let us assume any polynomial in which k is any real number. Suppose k will be 0. Let us assume that k is 0. It means k is 0. In which the polynomial, that is p of k is equal to 0. Now take example, that is 2x plus 3. It is the one of the polynomial. Okay. Now, so k is any real number, but its value, polynomial value is 0 already. So what happened here? P of x means p of k into 2 into k plus 3. Already the value is given 0. It is equal to 2k plus 3. Or 2k is equal to minus 3, or k is equal to minus 3 by 2. So this is what one value we obtain. So that is why the value of polynomial, value of px at x is the value of p of x at x is equal to k. What it generalize this problem or this example, consider this is another example. So what it says, consider any polynomial, consider linear polynomial. For this linear polynomial, already k is some other value of real number, it may be equal to 0. So on substituting, we will get the some other constant value or real numbers. That is why the value of p of x at x means x is replaced by any other number, it gives the k value. So in general, that is why in general, consider this p of k, it is equal to for linear polynomial, ax plus c. Here p of k is nothing but 0 because I want to conclude here by using general. Okay, so general form. The general form of linear polynomial is like this. Now what happened? K is k. Okay, here it is k plus c. So therefore k plus c is equal to 0, or k is equal to minus c, and k is equal to minus c by 2. Okay, because I consider the linear polynomial. What happened to general form? The general form of the value of the k is equal to minus c by 2. It means what it shows, why I could generalize it, because when you take any linear polynomials, suppose k may be any real number, their polynomial becomes 0, then on substituting you will be able to get some other real numbers, that is value of the k. But what happens in general form, how you can conclude that one? That is p of k is already 0, the general form of this one ax plus c, on substituting you will get the some other values of k. So that is what it says. The k is any real number which depends on the given polynomial in which the coefficients, which are those, minus c represents one of the number in the polynomial. A is also one of the real number in the polynomial. It is constant number and it is coefficient of the polynomial. That is why in the general form we obtain like this form. It means it shows us the linear polynomial of the any value or which is replaced by the variable, means a is replaced by some other value. So that is why for x is replaced by the value of k, you will be able to get the which is depends upon the coefficients and its constant values. That is today's class. So dear children, go through your textbook, thoroughly study. In the next class, I will take the classes on the how to convert the zeros of a polynomial by using the quadratic polynomials. Thank you.